issues. They are maybe possible that on some dead ends they are just colliding with each other. So to stop or to reduce such kind of accidents, or to even minimize such kind of accidents, we need GPS to be installed. So there are a lot of things you can understand that these things are coming into the picture. So when we go into the industries, means step by step, you can understand that a lot of entities came. Okay, I told you from the start. Okay, so now what exactly happens, like some, since we are going to install SAP, let us suppose, or ERP applications, and we are going to install some GPS applications. So some application is there, so simulation and training applications are required. Now we are automating the industry as a whole, so different departments are getting automated. So that what may happen, that those automation may have certain applications, and those applications must be, on those applications the users or the employees must be trained upon, correct? Similarly, network management becomes a very important aspect. Similarly, since we are discussing about different departments which are working homogeneously, so different users having different interfaces, local interaction management, telecommunication networks, and so scheduling, planning, optimization of logistics and supply chain management, control system management, and then simulation modeling to guide decision makers. Now what happens actually, why we are discussing all these things? Because we want that the management who is sitting at the top, they must be able to take decisions without any biasness. Okay, now you may think that why this particular case study I took. You see, so whatever we are discussing in terms of programs and application programs or users in the form of people. Now just visualize that all these activities, they are getting done by agents. Agents here meaning that they may be either people or some software agent, or some hardware agent, like robots and all. Okay, so these things are actually getting evolved for last 10-20 years. Okay, and multi-agent system as a whole is actually a part of artificial intelligence. Or to realize the intelligence, this multi-agent system comes very handy. So if we install or we implement such kind of mechanisms in the mines, the operation becomes very easy. At the same time, the productivity increases. Definitely cost is there, but initial cost is there, and then it depends on the means mine to mine utilities also, it depends. Okay, so now there are different operations that are going on, and all these operations are interrelated. So if these agents, like human beings, are working there, so definitely these human beings think, they take certain decisions in real time. So when we are asking the agents to do those operations which are currently being done by the human beings, and definitely a question comes into your mind, and it should come in your mind, that human beings are effectively, efficiently doing these operations. Why do you need agents? You see, what happens, we want the human lives to be lost less. The loss of human lives should be less. Okay, and a lot of human lives we are losing every year in such kind of areas, industries. So we want the machines to do our work, and definitely when we are asking those machines to do our work, then certain level of knowledge processing, certain level of intelligence. Am I audible?
Yes, sir.
Yes, sir.
Okay, so that's why this topic becomes very important with respect to this particular application that, or case study that I discussed with you. Okay, so we should have a broad idea of what we are going to discuss, how is it implemented in real time, and what is the application in real world scenario. Okay, so you see, let's talk about the definition of intelligent agents first. So when we define an intelligent agent, it is basically an autonomous entity. Okay, and what it consists of: sensor and actuator. Okay, so what sensor does, they take certain observations, or they sense certain parameters in their vicinity. Okay, and what actuators does, actuator do? So actuators actually perform actions which are either the perceptions which are based upon the perceptions which are of from that are received from the sensors, or not necessarily perceptions are necessary. Without perceptions also some actuation needs to be done, some actions need to be taken, so therein the actuators come into the picture. Okay, so when we talk about intelligent agents, basically they do two important things. One is they have to learn, and second, see, when you learn you gain certain knowledge, correct? So when you are getting this particular knowledge, so you have to use that knowledge in different real world scenario to achieve the goals that are given to you. So that these two operations are very important in terms of intelligent agents. What one is to learn, and second is to use the knowledge gained from learning to achieve their goals, correct? Now, let's talk about certain characteristics of these intelligent agents. Okay. So you have to accommodate new problem solving rules incrementally. It's very important. Huh? I have actually colored this particular word. Why this incremental is important? See, many a times what we do is we think a very big project and we try to implement that project at a time and at the same time. Okay, that okay, on Tuesday I will be completing this project. What happens when you come up with that particular project and you show that project to your supervisor or your whoever is going to evaluate this that particular project? What happens that certain redundancies come, certain faults come. Why that particular thing comes? Because we have worked upon that particular project as a whole. We did not think about certain underlying assumptions. Maybe possible. Okay. Similarly, if you want the intelligent agents to learn and do certain operations, you should not think as a whole, because you are human beings. Maybe possible today you are thinking, see, you are making the devices or the agents intelligent. So when you are thinking that these operations today you are thinking certain operations to be done, maybe possible tomorrow in while you are sitting with a cup of coffee in the morning, another operation comes in your mind that needs to be implemented. So that's why the agents also must accommodate new problem solving rules incrementally. Start from the basic, apply the knowledge and learning mechanisms slowly and slowly, step by step. So what will happen? You are actually gradually making the systems intelligent, okay, without missing certain important aspects of it. Now you see why we want this intelligent agent to work. See, two aspects are there. One is online and second is real time. Okay. So even though human beings are efficient, but that efficiency comes with the more amount of time you are doing that particular activity. Okay. So the same thing, if you are asking the machines to do, you want that the machines must adapt itself online and in real time so as to perform those activities. Okay. Then third point is the intelligent agents must be able to analyze themselves in terms of three critical parameters. One is the behavior. You see, human behaviors change, and we are only implementing and we are only programming the intelligent agents. Definitely, their behavior also changes, and the change in the behavior may occur, or this is because of maybe because of different reasons. I can tell you one reason at this particular time stand. Maybe possible you are asking our temperature sensor to sense the temperature, and you have set a threshold of 35 degrees Celsius. So this threshold you set in the month of during May, June, okay, wherein actually it goes more than 35 degrees Celsius. So the same thing cannot apply in the month during rainy season and during winter seasons. Okay, so the behavior changes because of the environment, and these agents are actually working on what? So they are working on actually the environment. They are sensing the environment, and they are trying to actuate on the environment. They are trying to take certain actions on the environment. Okay, and when the behavior changes of the behavior of the environment changes, definitely the task was different. You are trying to do the task with, or the machines are trying to do the task with same efficiency, with same rules. So there may be some errors that are going to be produced, and the success rate gets hampered, or actually the success may be possible, may not be possible. So what we are I am trying to say with this particular statement is, the third point is that the behavior changes doesn't matter, because this is the real world scenario. In real world, dynamically the behavior changes. So errors may be produced, fine. The success may be achieved, may not be achieved. But what we want those machines to do, to learn from that particular scenario and try to come up with different rules, so that this particular scenario, if they actually get in the future, thus it will result in success only. Okay, so learning is important over here. So learn and improve through interaction with the environment. That's what I was discussing with you. Okay, and since a huge amount of devices are getting deployed, huge amount of machines we are seeing. You see, I have two different laptops at my home. One router is there, one Alexa app is that device, Alexa device is there, Echo Dot. Okay, so there are different two, three mobile phones are there. So the number of huge amount of devices are there, or are getting deployed and will be deployed in the future. So what will it result into? Large amount of data. So the learning must actually accommodate those large amount of data also. Okay, they will be able to analyze, and those machines must analyze those large amount of data effectively and efficiently. Okay, definitely, large amount of data is there, so the agents must have memory-based exemplar storage. And I'm talking about storage, and this is a very critical aspect. Okay, so the devices, their sizes vary, their characteristics vary, their operations vary, their applications vary. So based on that, their storage also varies. And so we cannot ask certain device which has to lift a particular rock to take the decision of whether that rock is red, white, or some other color, of some other color. Okay, so what I'm trying to say is that we need to understand that those, they are the machines. In the same way that we say that, or a student says that our parents must understand that we are human beings. We cannot give 6 exams in a day. Our teachers must understand that we cannot give 3 exams in a day, because we are human beings. Similarly, they are machines. They have certain capabilities. So what the characteristic over here says that we those machines must have exemplar storage, but their capacities, capabilities must also be kept into the mind. Okay, and definitely, since we are talking about the memory, we are discussing about the memory. Short term, long term memory is there, age is there, and so machines also have age, correct? So we must think of machines as as a human being does the function. Okay, and then only if we will be designing such kind of machines or intelligent machines, they will be doing the work in real world scenario with the characteristics that actually I have discussed with you. Fine. Now, very important aspect, since we have discussed about agents, but what is an agent that you must understand? Okay, so what exactly is an agent? You see, you are trying to when you are saying intelligent agent, you are trying to embed intelligence in an agent. But what exactly agent is? So agent actually is, it can be anything. I told you, no, like what can be an agent? You can see over here, an agent can be a human, robot, software, a piece of code or program, and anything can be an agent. But what is essentiality of that particular agent is that it 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 actually uses a function. Okay, and what that function does, that function maps the percept histories to actions, where P defines the percept histories and A defines the action. Okay, so now what is a percept history? So the sensor senses something, so that is known as perception of the environment. So sensor is sensing the temperature. It means that the temperature is getting sensed of an environment, correct? So the perception is for a particular environment. So we get a perception, and based on that perception, like we get a perception that the temperature has risen above 35 degrees Celsius, and based upon the rules that if it increases above 35 degrees Celsius, we must turn on, the agent must turn on the AC, okay, of that particular room. So in that case, what is the action? Turning on the AC after 35 degrees Celsius is reached. Okay, so what herein one important aspect that you must understand is I am writing P star. So what is this P star? If you have gone through automata, it is the same thing. So what I'm trying to say that it is not necessary that always perception happens, then only action takes place. Like I can tell you a very good example from your daily life कि ऐसा कभी नहीं होता है कि आपको प्यास लगता है तभी आप पानी पीते हो, है ना? Sometimes you go take the glass and fill it with water and drink it, है ना? ऐसा जरूरी नहीं है कि you are always thirsty then only you go and drink water. Similarly, it's not always that the actuation takes place when the perception, only when the perception is there. No, not necessarily. Okay, so that's why it is written here as P star. In the absence of perception, also periodically some actuation takes place. Okay, so that's what the concept behind it. So this is what the structure of an agent essentially, and I would like to specify over here that there is a very good terminology that is known as utility. You know, utility. So what is this utility? So I can specify that utility UI, again, it is a function that maps from set of states S to some real value R. Okay, so what is this R? This is some real value. Now I can give you a very basic example of utility, you know, like your mother is asking you to go to the market, and they are saying that if you go to the market and purchase vegetable, I will give you 100 rupees. So what is actually going on? You are at home. Your home is what? State S1, correct? And you are changing your state to S2, which is actually market, correct? And then you are reaching S1 again. Okay, I can say like this. So you are reaching S1 again. On reaching S1, that is your home. So you are given 100 rupees. What is that 100 rupees? Your reward in the form of some real values. So this is what actually the utility is. So why I'm specifying this particular concept of utility? You see, you are asking the machine to do certain activity, and like you are asking a robot to open the door. But it's not like a robot will say that, okay, since you are asking, I will do. And it's not like in real life also. And you two are brothers and sisters. You ask your sister that I go and turn on the fan. Sometimes she does because okay, fine, she is also sitting in that particular room. So what is getting implied over here? The implication is that she is trying to think about her own, means when she is thinking that she is in the same room, so she should turn on, she should think about her elder brother. So basically, she is also thinking that since she is in the same room, she is also feeling the heat in that particular, correct? So what we are trying to give, we are asking the agents we are asking the machines to work based on certain rewards. If you do this, I will give you this much of reward. If you do this, not only money, the reward can be anything. The reward can be in the form of energy consumption. That reward can be in the form of, you can ask the machine that you did a lot of work, you just sit idle or you just sleep for next 8 hours. I do not want you to work for next 8 hours. So what is going on? The reward is very important for that particular machine, because if that machine sleeps for 8 hours, that machine is actually conserving its energy, and that is very important. And so this is the concept of utility, and it is related to the structure of the agents, how agents operate. Okay. Now let's talk about the definition of multi-agent systems. Hey, what happens? Definitely, multiple agents are there. Right? So it consists of a number of agents which interact with one another. How they can interact? With the use of certain software programs, by exchanging messages through some computer network infrastructure. So their computer networks is very important entity of a multi-agent system, and a lot of agents or a different number of agents are very important entities of this multi-agent system. Definitely exchange of message. Okay, that is very important entity, so we have to create certain software code for that. And so this is all that comes under the definition of the multi-agent systems. But we must understand two key problems of working with multi-agent systems. First is the problem of agent design. So you have a multi-agent system, there are different agents in that multi-agent system in that particular system. Now, how you can design an agent? So the design of an agent is dependent on what? Do you want those agents to be independent or dependent on each other? How much amount of autonomy is needed to take certain actions? Okay, and what are the different tasks we are going to delegate? What are the different tasks that they are going to do on their own? So we have to think about a lot of design parameters, and hence the agent gets designed. So this is one of the key problems of multi-agent system. Problems means I'm not talking about the limitation wala problem. Okay, I am talking about the problems means what we are going to address. Okay, for which solution is needed. Now you have agent, you want those agents to interact. It's you can have an analogy with the society wherein you live. So you are having a lot of people, different human beings are there, they are living. Okay, so if you want to celebrate Holi, Diwali, what you need? So somebody is selling the crackers, someone is going and purchasing those crackers. So somebody is paying, somebody is getting the money. Okay, so what is going to be going to happen over here? We are actually designing the society. So when there are a lot of agents, part of the multi-agent systems, we are trying to design that particular society. This is also one of the critical challenge. Okay, because we are going to introduce the concepts of cooperation, coordination, negotiation, delegation. Okay, we are going to discuss about the concepts related to how the arguments takes place. I'm not talking about ladai wala argument. Okay, so arguments means when you are trying to negotiate, in those cases also you give certain argument one, I give certain argument two, and then we negotiate on those things, two arguments. Okay, so argumentation takes place. So all these things are actually part of the society we live in, है ना? And if we are trying to design a society for the machines, therein we have to implement these concepts. So these two concepts are very important in multi-agent system. One is agent design, second is society design. Now there are certain questions that we need to address. What are those questions? Like, first question should be, how can cooperation emerge in societies of self-interested agents? Definitely all the people, all the agents or machines are self-interested, like they are selfish. And don't take selfish in negative sense over here. Okay, when I'm saying selfish means they are thinking about their own utilities. Okay, yeah, how much reward I can gain. So what happens if they are trying to gain more reward? It means that they are trying to do more work, and that's what we need from them, that they must do more work and they must do those works efficiently. But when they are self-interested, they are thinking about themselves, then what kind of mechanism or protocols you can implement with which the cooperation comes into that particular society of those agents. Okay, second thing is what sort of common languages can agents use to communicate their beliefs, aspirations? Now they are acting like normal human beings, so they have certain beliefs also. They have certain aspirations to take that particular task, to achieve that particular task. Okay, and they will be communicating because we want cooperation. So they will be communicating those, like it happens now. Your faculty says that submit the work tomorrow. You say that, madam or sir, we have a lot of assignments given that which need to be submitted tomorrow. Could you please just shift the submission date to be the day after tomorrow? So what you are trying to do, you are trying to communicate your beliefs, your aspirations, your arguments in front of your faculty members. Okay. So similarly, if certain such kind of scenario happens wherein it should be a win-win case rather than you do whatever I am trying to say to you. So what in such cases, we should come up with a common language. This is one of the problems that we must also work upon. Okay, then comes you see, how can self-interested agents recognize their beliefs? Okay, I'm saying that those machines can argument, they can produce those arguments, and they can put up their opinions. But actually, if you see a student who is in third standard, if you ask them to do the work, they will not produce such kind of arguments. In sixth standard, seventh standard, the argument, so slowly those arguments increase, because you try to also become means, you try to go into your comfort zone, and you try to know about you, है ना? So or you have other things also that you are doing with age, means as your age increases, correct? So similarly it happens with machines also, and that's why, if you remember in the first slide, I told you that the all the implementations must be incremental. Why? This is because of this only, है ना? This reason, that your beliefs, goals, actions, so how those machines are going to understand that. Okay, and whatever the questions I'm trying to address over here, basically I'm giving you the research problems or project problems to work upon. Okay, and how can autonomous agents coordinate their activities, okay, to cooperatively achieve the goals, है ना? So there is a local view. Local view means if I am sitting over here, I can only understand what is going on in Jaipur, okay, or in my society. Fine, you are sitting at your own place, so those are your local views. Similarly, when the agents are working together in a particular field, some agent has certain perceptions, second agent has certain perceptions, so they must combine their perceptions, they must interact with each other to let each other understand the perceptions, so as to come up with a global decision to achieve the to come up with a global view and achieve the goal, correct? So this is also one of the questions that we need to address, or a research problem that we need to address, correct? Now let's talk about certain vision things. Okay, so you must be having this in mind. What is this? What are the applications? Like, I can give you an example over here. So like, you can understand, unexpected system failure happens. So there is a space probe that is going to the moon, and it has lost its contact with Earth-based ground crew. That happened with our landing rover, correct? With our moon mission, correct? So now what happens, that a sudden system failure is there. So what could be one of the solution? That we must have an agent that will be responsible to take care of system failure, diagnosing that failure and isolating the fault and trying to rectify the fault, so that the connection with the ground crew on Earth can be made. Okay, so this is one of the applications of multi-agent system. Second is, you see, air traffic control system. Let us suppose New Delhi airport is there, and suddenly, due to this air traffic control fails, some flights in the vicinity, they do not have certain decisions or support from the air traffic control. So what will happen? There may be trouble with the aircraft. They may collide with each other. There may be certain accidents that may happen, and you might have seen in last 1 and 2 years, so many accidents happen because of such kind of scenarios. So what we need, some autonomous air traffic control systems. So therein we have to install such kind of agents to actually come out from these disastrous situations that may happen, correct? Now, there is one another scenario. You see, if you about UK, it's either raining or too cold, and it's raining throughout the year. So there are different reasons. Actually, the environment is like that only. Okay, geographical region is like that. So the scenario over here is that after the wettest and coldest UK winter, so you are in desperate need of a last minute holiday to some place which is a little bit of warm and dry. So what will you do? You actually go to your personal digital assistant, and you ask it that you give me some of the places. So it searches the different websites and gives you the details about the flights, hotel rooms, hire cars. Okay, so what have I done in this particular slide? I gave you some examples of a software agent. I gave you one example of a hardware agent. I gave you one example of soft bots. Okay, so similarly, I can give you an example. If you go to IRCTC website or ICICI website, a help desk suddenly comes up named Disha or iMobile saying that, do you need something? Do you need some help? Okay, so those are the software agents, okay, which are actually working for you and trying to solve your queries. Okay, so these are some of the examples where multi-agent systems have or the agents as a system or agents are actually helping us in our day-to-day lives, and it is getting evolved day by day. They are learning, and their learning is getting evolutionized because of certain advanced algorithms we are trying to implement incrementally day by day. Okay, now basic research problems are there, like how do you state your preferences to your agents? PDA. Okay, when you are personal digital assistants, you are asking, so your preferences must be given to the agents. So how are you doing that? How can your agent compare different deals from different vendors? So you have to devise algorithms for such kind of scenario. You are trying to say that the negotiation must be there between the agents, but what kind of algorithms you have to come up with? Okay, and since these are the basic research problems, and so some views you must understand. So one view says that agents must be treated as a paradigm for software engineering. Definitely. See, you cannot say that, okay, I am a hardware engineer, I will not work on any software. No, you have to. When you are saying that those two hardwares are trying to communicate, or they are trying to cooperate, certain level of software must be created, correct? And those software will be helping those hardware to communicate. So definitely we must think in this particular we must have this particular thing in mind at the time of implementation. Second is, agents must be understood as a tool for understanding human societies. I can give you an example, like two brothers are there, A and B. So mother says that you go to the market, okay, and you purchase the vegetable. Whoever goes, I will give 100 rupees. So they must initially decide who will go, because if both will go, they will not get 100 rupees because mother is going to give 100 rupees only. So first, what is the first thing that they can come up with solution? Okay, we will both go to the market. We will take half of vegetables so that we will get 50 rupees. But this is not a feasible solution every time now, because both of them are not free. So what they can come up in incrementally, now incrementally in the second increment they can come up with the decision that, okay, day one I will go, next day you go, then alternatively we will go. So alternatively we will get 100 rupees from our mother. Then suddenly what happens, that they come up with a different problem, that someday first brother is sick. Okay, so now when the first brother is sick, the second brother has to go. So now herein a negotiation or a certain level of cooperation is needed. So now you are understanding how learning comes into the picture. So the cooperation is needed. So the second brother goes, but when he comes back, he has two options. Either he will not give money to his brother, and second option is he will, since he has done more work, he can give 25% to his brother because it was his day on which he has to do. So different options are available. Similarly, may be possible that this is a very good option. They are going further, and suddenly it is observed that even though one of the brothers is not sick, every time he is giving that particular option excuse of being sick, and the other brother is doing the work. So in that case, he has to think selfishly. He has to think about self-interest, that every time I am doing the operation, no, I will be only taking this money. Okay, so what is happening? The machine is getting the decision making capability of the human beings, or the both the brothers are getting evolved, and such kind of capabilities. So this is how the human societies work, and such kind of capabilities we want for our machines also. Correct. Now, there are certain objections to multi-agent systems. Now, definitely, when I say objections, I'm not trying to say that multi-agent systems are bad or a bad or a very worse field to work upon. These objections are basically what we means with the help of these objections, the researchers or the society wants us to work on these particular problems. Like, is it not all just distributed on concurrent systems? Okay, all of them are working together, correct? So we have to come up with certain algorithms wherein we have to specify that it should be centralized in nature, the communication should be distributed or concurrent in nature. Okay, then is it not all just artificial intelligence? Definitely it is artificial intelligence, but it is a branch of artificial intelligence wherein, see, artificial intelligence, what happens? We are discussing about agents and the environment. But when multi-agent comes, there are a lot of agents. So those agents, the cooperation, coordination, collaboration among those agents. So we must take care of those activities. Fine. Then is it not all just economics or game theory? Because I have been discussing about utilities, correct? Getting rewards and all. So it comes under economics. So we must think about economic aspects at the time of implementations also. We must think about certain game theory algorithms and implementation mechanisms for designing an effective multi-agent system. Fine. Is it not just social science? Yes, it is social science only, correct? Because the society, how they operate, we are trying to make our machines to work like that only, to just simulate or emulate our society as a whole, correct? So what I'm trying to say with these objections, I want you to go through these point or these aspects of and go into the detail and try to think about the suitable solutions to a particular problem in this particular domain. Okay, now let's talk about learning in multi-agent systems as a whole. We have been discussing about multi-agent systems. I was having this in mind that a lot of people are very new to multi-agent systems, so that's why I thought why not to take up on some of the topics to let you understand. Now we are going to discuss about what basically is learning in multi-agent systems. You see, when we talk about learning, learning is means you can the meaning of learning can be taken from remembering to deduction. Okay, so you try to see certain things for the first time, you try to read about certain things for the first time, then you try to remember, then slowly some new problems come, so you have different domains of remembrance. So you have different domains in which you have read. Now when some problem comes in front of you, you use certain means one or two or three of those domains to and remember some of the ideas or things or thinking process. Okay, and then you apply that to deduce the solution. Okay, so that this is what, and you need, you see, the reasoning can be of two types. One is induction, second is deduction. So what do you mean by deduction? So Aristotle's concept was deduction. Deduction में क्या होता है? You have a theorem, you try to prove it, and you try to give certain examples to prove that okay, this is the correct way to analyze this particular theorem. Now, what is induction? So induction is you have certain um, uh, uh, evidences, you collect those evidences to come up with certain conclusion, and then you devise your final theorem. Okay, so deduction is like what Aristotle does and what Sherlock Holmes Sherlock Holmes does, that is what induction he does. Okay, he works on the principle of induction. He has certain facts or evidences, he collects them, and then he finally comes up to a conclusion that that particular guy was murdered by person A or person B or person C based on the facts or the evidences he collected. So this is what the difference between deduction and induction. Okay, so when we talk about learning, there are two categories of learning. One is cooperative learning. What do you mean by cooperative learning? So you see, when we talk about multi-agent systems, they have the goal of exploration or monitoring of a given space. So I told you that each agent has local view of its own area. So we want that local view must be mapped to the world's view or the global view. Okay, so for this particular mapping of local view to global view, those machines are interacting with each other, and during this interaction they are trying to learn from each other and the environment as well. Okay, because the environment is also changing. So with changing environment, they must be able to capture they must be able to capture that environment, and hence cooperatively decide on what to do, what not to do. So that's why this kind of learning is known as cooperative learning. The second kind of learning is known as competitive learning. See, I told you already, every agent is selfish. Selfish means they are trying to think about maximizing their own utilities. Fine. So you see, they have certain behavior, they have certain weaknesses, correct? So we and you see, the system dynamics are also changing. Some means maybe possible that a pole is there, an electric pole is there at a particular location, and suddenly earthquake comes and it shifts its location. Okay, so the real world scenario has changed, so the GPS location must also gets changed. Is does it happen in real world scenario? So that accuracy must be maintained. So what I'm trying to tell you is the dynamics of the system is also getting going to be changed. So the all the agents have their own behavior and weaknesses. Now we must be able to capture those behaviors and weaknesses, and we have to think about own means maximizing our own utility. Why? Because we want an equilibrium to be achieved. Okay. Now you see, when I talk about equilibrium, it is a state of balance. Okay, if I am the designer of a particular multi-agent system, I do not want my agents, which are my child, that one agent must be at loss, another agent must be at gain. No, I want all the agents to come up with a solution in such a way that they come to a state where all the agents must be gaining something, or if they are even losing, they are not at a loss in such a way that means they are behind some other as compared to some other agents. Okay, that's what we want. As means, if I see as a faculty also, if I teach 60 students in a class, I want all the students to pass. Correct. So similarly here also, so competition, so healthy competition must be there in that. So this particular environment where the competition comes and learning is achieved on the basis of that competition, that is known as competitive learning. Okay, and whenever we say this term called competition, so game playing comes, so game theory comes. John Nash, आपने देखा होगा, कहाँ देखा होगा? ब्यूटीफुल माइंड मूवी देखी होगी, है ना, जॉन नैश की. So he worked on the concept of game theory only. Okay, so he gave this Nash equilibrium concept. So read about that particular concept, Nash equilibrium. ठीक है? So we have to come up with a particular decision in such a way that all the agents are getting benefited because of that particular decision. Okay, so that's what the concept behind competitive learning. Now, what we are going to be, we are concluding this particular example. We are concluding that all the agents might learn. Why? Because they do not know everything about their environment initially or during their operation also. Okay, because the environment characteristics are changing, the dynamics are there in that particular environment. Secondly, they do not know how the other agents behave. They have to cooperate or they have to learn somehow. Right? And the learning can happen in a cooperative environment where agents share their learned knowledge, and that learning can happen in a competitive environment also where the agents try to compete with each other. Why I am explicitly giving this particular scenario? You see what happens, when students go for a project, when researchers go for a research, they often start, chalo, ye implement karte hain. You think the basics, you think in your own way, means now you go and implement some algorithms for cooperative environment, go and implement some algorithms for competitive environment, and understand how those algorithms are actually emulating the real world. Okay. Now, there are certain general theories, let me just hide it. Okay. So, when we talk about learning agents now as a whole, so there is a general theory behind learning agent. There are certain assumptions that we must understand. Okay, ऐसा नहीं होता है कि चलो learning agent बनाते हैं. No, there are certain assumptions. What are? So let's first understand why learning agents are important. You see, the circumstances are unknown, and because I'm always saying that dynamically the environment, real world scenarios are changing, so agents may face such kind of scenario. So agents may have taken certain actions and failed. So if there is no learning, they will do the same operation and they will fail. And the point of creating that particular agent is actually it is a failure. Okay, basically. So we want them to learn because we do not want them to those agents or machines to repeat the mistakes again. Correct. So theory of learning is actually a tool to determine the possible equilibrium point of the system. That's what I discussed you. What we want, a state of balance must be maintained in the system. Okay. And this particular theory of learning is important for that. Okay, how we will see. Okay, so why the equilibrium system means solution of a system is unpredictable in nature. You see, there is an existence of unpredictable environmental changes, and agent has access to its own set of payoffs. Now, what is a payoff? The utility that I discussed. Okay, I know about my own utility. If I have gained it, if I have lost it, I know about my own utilities. Fine. Similarly, so to work effectively in a particular system, I must know about the utility of another system. On the same, trying to say over here is that if we know about each other, we will be able to come up with proper solution. So there are certain behavior that must be mapped, like the moving target function is there. I told you, no, the target changes from here to there because of environmental characteristics. So actual payoff also keeps changing. So if two agents are there, agent one says gives means communicates that hey, agent two, I have 100 rupees as my payoff. What is yours? So agent 2 says that I have 200 rupees. Now, when agent 2 is replying, he is knowing that agent 1 has 100 rupees with itself. But maybe when the agent 2 replies, agent 1 has done certain operation, and because of that, the utility or payoff is increased. So there is the actual payoff also keeps changing. Non-stationary dynamics are there. And see, game theory suggests on equilibrium points, but you see what happens, payoffs stay fixed. Multi-agent systems never converge to those points. And being designers of the multi-agent systems, we must understand how to converge to those points. Fine. Okay, just wait, let me turn on the charger. So, there is a model known as CLRI model. No, what it does, it provides a method to analyze the learning agent systems. Fine. Particular method we are going to discuss. What is this CLRI model? C stands for change, L stands for learning, R stands for retention, I stands for impact. Okay, so because of the changes in the environment, okay, what is the learning, what is the retention, and based on those learning, retention, and change, what is the impact? And because of when we are trying to model this, we are trying to basically come up with a solution for the learning agent. Okay, so what we are doing, we are, see, there are a lot of agents. Okay, maybe possible that a particular task is given to you. Okay, बता दिया जाता है आपको कि okay, you are two students. Do one thing. You have to paint this particular room white. Fine. Now, one student thinks that I should start from first. So what will happen, because of some student has started first and painted the ceiling, there may be change in the decision of the second student. Similarly, if somebody started and painted the walls first, the change of the there is a change in the action of the second student. Okay, so what I'm trying to say is, always it happens that when we are living together in a society, because of the actions of certain human being, the others actions also gets impacted. So when we try to determine the effect of one agent's learning of other agents, therein actually we use the concept of CLRI model. Okay, so in this, we have certain assumptions. What are those assumptions? Like there is a fixed set of autonomous agents. Agent has a decision function. What is this decision function? So this is the behavior. Okay, this is the behavior. And the system also has a target function which is unknown to all the agents. Hai na? So what is this target function? Actually, it is the best possible behavior. And one is behavior, one is the best possible behavior. Behavior is how you are learning, you are designed, your knowledge is there, you are educated. Okay, and best possible behavior comes when you think, when you think, see, visualize, you perceive the others, and you come up with best solution to a particular problem because of the best possible behavior shown by you. Okay, so the target function can be achieved when best possible behavior is there. Okay, and why all these things we are doing? Because we have a goal that whatever the decision function is, it must be the exact duplicate of the target function. मतलब कि आपको अगर मैंने कह दिया है कि आप एक पर्टिकुलर रूम को पेंट करना है, ओके, सो वॉट एवर योर डिसीजन फंक्शन इज, एक तो क्या होगा, फर्स्ट टाइम आपका डिसीजन फंक्शन क्या होगा कि ओके, आई विल स्टार्ट फॉर द फर्स्ट टाइम, आई विल पेंट द होल रूम एट द सेम टाइम, है ना. सेकेंड डिसीजन फंक्शन क्या होगा कि आई विल paint a wall on the right, then wall on the left, then wall on the north, something like that. Third decision function. So whatever your decisions you are taking, so how accurate is those decisions? So accuracy कब होगी? जब जो पूरा रूम पेंट हो जाएगा. तो हो सकता है आप पहला डिसीजन जो लिए वो इस तरीके से लिए कि पहली बार में पेंट हो गया, या फिर आप इंक्रीमेंटल डिसीजंस ले रहे हैं कि वॉल करेंगे, सीलिंग करेंगे, है ना, समथिंग लाइक दैट. सो I'm not saying that anybody is wrong. I'm saying that we need to learn so that we can do that particular operation with minimum time, with maximum throughput, and with minimum cost, and at the same time minimizing or conserving our energy is very important. Our energy means I'm a machine, that means being a machine, I'm discussing it with you, correct? So how CLRI model can be formally defined? So it has, I already told you, fixed set of autonomous agents. It has discrete states. Now, when I say discrete states, what are those discrete states? What do you mean by that? So you see, let us suppose that this is S1, S2, S3, S4, okay, S5. Fine. So now there is a robot in your house. You ask your robot that you have to open the door every time the call bell rings. Okay, so now the robot is static. So first state is it is statically deployed. Okay, it is sitting somewhere, that robot. So it is in state 1. Now as the call bell rings, it has to go to some state S2. Fine. So discrete states, when I'm saying, so we have to think likewise. It has to go to S2. What is that S2? To start running. The robot has to start running or walking towards the door. So now it is in state S2. Now from S2 it goes to state S3. What is that? It has to stop when door is found. Stop when door is found. Okay. Now what it has to do? It has to search, it has to go to some S4. What is that S4? It has to search for how to open the door. And then it goes to the from S4 it goes to S5. What is that S5 state? S5 state says that it has to open the door. Fine. So similarly, when door is opened, it can just go to its state 1, that is it is now idle. It is sitting statically either beside the door or it just at the place from where it started. Okay, so why I gave you this particular scenario? Because whenever you are coding, you have to think likewise for such kind of for making your means intelligent programming. When you are doing, you have to think likewise. So this is one very real life example that I try to connect to you with. Okay, So these states are having certain probability distribution also. Na? What is the probability that you started, but you will be able to reach that particular door? Maybe possible that your battery goes out and the robot actually stops in between. है ना? So this is what the concept there. So agent I has set of possible actions. है ना? So I told you, na, it has to start, it has to run or walk, it has to go, it has to search. So these are the actions of that particular robot. Time is discrete, definitely. It has started at a particular time. It has reached the door at another time instant. है ना? Similarly, agent I's behavior is defined by a policy. It has to actually, what is that policy? So it has to map your state to the actions. है ना? What you are actually going to a particular state when you are taking certain actions. So that action must be mapped with a state. Okay, when you do certain actions, you are changing the state from I to J. है ना? And you that agent must have certain optimal policy associated with it also. है ना? And that optimal policy है ना, और जो एजेंट का जो आपका जो बिहेवियर होता है for that particular policy is there, उसके बीच में जो difference आता है, that is what discrepancy is. Like I have specified that, hey robot, you have to open the door within 15 minutes, within 2 minutes of ringing the call bell. Okay, but maybe possible due to certain reasons, more number of obstacles, it is trying to change its orientation while going towards the door, and instead of 2 minutes, it has taken 3 or 4 minutes. So what is the discrepancy? 4 - 2 or 3 - 2, that is 2 minutes. So it has taken 2 more minutes to reach the door. Okay, so that discrepancy must also be there. And what is the probability of taking wrong action? Maybe instead of opening the door, it has just broken the door. So that error is also there. So that must be also understood, and it must be mapped. Okay, so these come under the initial assumption. Formal definition means initial assumptions that we must take care of. There are a lot of other assumptions also based on different scenarios wherein multi-agent systems can be applied or the learning can be applied. Okay, so the different terminologies or 4 parameters that I discussed. What is that change rate? So this is the probability that an agent will change at least one of its incorrect mapping. What is learning rate? So agent changes the incorrect mapping to correct mapping. है ना? एक बार गलती हो गई है, लर्न करने का मतलब क्या हुआ कि नेक्स्ट टाइम वो गलती नहीं होगी. So incorrect mapping is converted to the correct mapping. Correct. So this is what the learning rate is. Probability. So your learning rate should be always less than or equal to change rate. है ना? अभी क्या है, अगर learning आपकी change से ज्यादा हो रही है, there must be a balance between that ना. So when you are learning more than the change is happening, so what will happen? You have learned a lot unnecessarily, and your change is happening too frequently. So let the change happen and then learn based on that. Okay. So there must be some optimization between that also. So retention rate, what is that retention rate? That when you have learned and you have changed your incorrect mapping to correct mapping, now what is the probability that always you are doing the same action so that the correct mapping is getting achieved? So that is your retention rate is. Then comes your volatility, very important. Now you see, I told you ना कि वो जो pole है वो due to earthquake change हो जा रहा है from here to there. So what is happening? The target function is getting changed. You are giving a target. आपको बता दिया गया है कि भाई 2 दिन के अंदर इस room को जो है paint करके देना. Now what happens that after you have not completed within 2 days, and on 3rd day it is told to you that no, with this room I want within 3 days from the start, within 3 days I want 2 rooms now. Okay, so what is happening? The burden is getting increased. So we have to take care of this target function also. So volatility, what it actually tries to find out the probability that the target function changes from time t to time t plus 1. So actually it is trying to capture the amount of change an agent must deal with. Hai na? So based on this volatility, there is a 4th parameter. Actually, this is the 4th parameter, that is your impact, that is denoted by 2 dimension I, capital I, small j, where these I, small j are 2 different agents. agent I and agent J in that multi-agent system scenario, and it tries to represent the impact of I's learning on J's target function. See, initially the target function was same. जैसे मैंने बताया था ना कि दो लोगों को बताया गया है कि एक रूम को पेंट करो. So one person is seeing that okay, I will start by painting the ceiling first. Second uh, decides that okay, no, I will paint the wall first. So what will happen if one person has completed the ceiling? Okay, then the target function of the second also changes. Okay, now it has to not paint the whole room, rather it has to paint the walls now, correct? So we have to see that. And when we are having these four parameters, what we can do is we can try the expectation of, we can try and find the expectation of occurrence of error. Okay, so this is denoted by capital E, expectation of error, and it is at time t. I told you discrete times are there for what? For delta I. What is this delta I? Delta I is the decision function. Okay, and delta I is mapping which may be correct and may not be correct at some time t, t plus 1, t plus 2, fine. And this is actually determined for whom? For a particular agent, है ना? For an agent. What is that agent? Here I am specifying I, so this is the ith agent, correct? So ये सब क्यों कर रहे हैं हम लोग basically? Because this is one of the tools I wanted to give you कि भाई जब आप learning agent को create करोगे तो you have to think. This is a very basic thinking that I want to develop inside you, from where you can start and you can think in more complex terms. Okay, so here in what we are trying to do, we are trying to minimize the error, and we are trying to minimize the distance between target function or gap between target function and the decision function, because we want our decision function to be duplicate of the target function. भाई पहली बार में ही सही डिसीजन लेगा ना मशीन, क्यों उसको इंक्रीमेंटली करना है? वी आर ट्राइंग टू मेक दोज मशीन्स टू or design those machines to work incrementally, or we are even designing those machines in an incremental fashion. But after learning, those machines must take decisions in real time at one instant. Okay, considering the situation is getting changed too often in real world scenario. Okay. So what are the observations? You see, when your learning rate is very high, there is a change in decision function that almost matches the target function. Correct. And when you have low volatility, I told you what is volatility? The probability that it changes from time t to t plus 1. Hai na? So when there is a low volatility, definitely target function will not move a lot. Hai na? And when we talk about the impact, you see what we want equilibrium to be achieved. So convergence must be there for a particular system. Okay. So when they will converge, when impact is as low as possible, or in this case, what I am specifying over here that Iij is equal to 0. It means that I's impact on J's impact on J's learning is actually 0. So what it will mean कि भाई अगर आप भी independently काम कर रहे हो, मैं भी independently काम कर रहा हूँ, and we are actually not, our impacts are 0, it means that we are actually working independently at we will be going to achieve the result in on time actually. Okay. Because if the target function changes on the basis of learning, my impact changes, then I will again decide on a new target function, and then I will do all these activities, and then I will decide. And this takes certain amount of time, even by human beings. So definitely machines will take certain time, and we want to reduce that time, correct? And when the impact increases, the system will never converge. So we have to reduce the impact. Okay, independency must be there. They must cooperate, but they must work in such a way that it's not like कि भाई तू पहले सीलिंग कर ले तब मैं वॉल कर पाऊंगा. अगर सीलिंग नहीं किया ऐसा नहीं होता है ना. One can do ceiling and one can do wall concurrently, correct? Now, you see, to stop, I will be stopping my presentation, I will be stopping my talk by giving you certain famous algorithms of learning. So you might you might have been hearing about machine learning a lot. But what exactly is the goal of, you must understand. What exactly is the goal of machine learning? With machine learning, we want that certain algorithms must be developed that increases the ability of a particular agent to match set of inputs that we have to the set of outputs that we have, correct? So let me give you an example. If you say that we have E, है ना, what is this capital E? It is a large set of example, some large set, okay, and we want that there is a small e that belongs to capital E, which has, which is a set of A comma B, but where what is this A? A is the set of inputs and B is what? B is the set of outputs. So what we are trying to do, we are trying to develop algorithms. When we go for machine learning based research, what we are doing in machine learning, we are trying to develop algorithms that increases the ability of some agent to match set of inputs, this set of inputs with set of outputs. Okay, this is what we are trying to do. Okay, I can give you an example. Let us suppose there is a function that maps A to B. Okay, wherein what is this A? So A is set of photos, set of photos. And what is this B? Male or female. Okay, so when I write E is equal to A comma B over here, what I'm trying to specify that A is set of photos. So based on this particular photo, I will take some photo from A and I will try to recognize B, that is our set of output. ये input है ना, ये output है. So based on photos, I will try to recognize whether this is a male or female. है ना? So इसी को effectively करना है. So this is when you are trying to give this particular task to your machine. So this is a very basic thing that I have discussed with you, है ना, with respect to machine learning. Set of inputs को set of outputs के साथ करना है. So what happens in case of machine learning? So when we say that machine learning problems are there, है ना, machine learning problem is there. So it can be done with two process. One is controlled test. One is control test and second is testing set. Okay, so what do you mean by control test? इसमें क्या होता है? पहले आप क्या करते हो? You divide the training set and train the agent based on your division. And testing set में क्या करते हो? You try to find the performance of the agent. Fine, you try to find the performance of the agent. Like, I can give you an example. What could be the example? You see, if I represent graphically my machine learning problem, okay, and I say that I have set of input. What is that set of input? So if this part specifies the speed, this part specifies the weight. Okay, so what is my input? Input is speed comma weight. Okay, and some values I am getting over here in the form of what? Plus, minus, plus some values I am getting. Fine. So what is my output? Output is plus minus. Fine. So what I am trying to do is to map my input with output, है ना? तो अभी इसके लिए क्या करेंगे? पहले हमें functions बनाना होगा, ठीक है? तो let us suppose there is a function f1 that maps your minuses. हमें minuses को map करना है. Let us suppose that is our goal, है ना? That's what I didn't tell you. My goal is to find the number of minus values in this particular graph. Okay, this is my goal. So this is, let us suppose, function 1. Okay, so there may be another function, you know. What could be that function? So that function could go like this. है ना? So what is this function? Function f2. There may be some another function, you know. So this function may go like this. And now, what is this function? This function is f3 function, correct? So what I'm trying to tell you is, even though we got f1, f2, f3, three different functions, we are actually having a classification of the functions correctly in such a way that we get the different solutions of this particular problem, that is to find the number of minuses in this particular graph, है ना? So अभी क्या है, मैं ह्यूमन बीइंग्स के टर्म में बता रहा हूँ, इसी को मशीन के टर्म्स में समझने की कोशिश करो, ठीक है? विजुअलाइज कि भाई इसमें लर्निंग कैसे होगी, कि भाई नाउ 3 फंक्शंस कैलकुलेट हो गए, इसके बाद अब मशीन क्या सोचेगा, अरे विच वन इज बेटर, है ना। तो वहां पे क्या कंसेप्ट आता है, इंडक्शन, बायसिंग नहीं होनी चाहिए, है ना। मे बी पॉसिबल कि समय अदर फंक्शन हुआ है बिकॉज वो बायसिंग, देखो ये वाला जो F3 फंक्शन है वो प्लस के पास से गुजरा है, इट इज नॉट नेसेसरी, देखो F1 इज मैपिंग इट प्रॉपरली, है ना। तो next time the machines will take upon this particular case and they will ensure that the function f1 will be utilized if the same problem or same set of problems will be given to you, okay, or given to the in the environment or found in the environment, fine. So this is what the concept behind your machine learning problem, you know. And you see, cooperative learning I have discussed a lot, and you can work upon this. There is another learning mechanism, learning on the basis of repeated games. There are different players. These agents are different players. Now you are actually play those players are playing games with among them. है ना? Okay, you do this particular activity, you will get this much amount of bonus. I do this, I will get this. If you will be able to do in stipulated amount of time, you will get bonus. If you are delayed, you will not be getting any bonus, something like that. So there are very basic algorithms of repeated games like fictitious play, replicator dynamics, awesome algorithm. There is a algorithm name that is awesome algorithm. So you can look into these algorithms and try to start your learning, implementing the learning mechanism in multi-agent systems with this particular approach. Then we have stochastic games. What do you mean by stochastic? You see, if we go to the literal meaning of stochastic, you see some random probability distribution is there, है ना, which can be analyzed using the concept of statistics, but it is actually difficult to predict accurately or precisely. Okay, so stochasticity is in itself a research problem. We can use the concept of stochastic games to come up with learning algorithms. Okay, then a lot of people, you guys must be reading about, or you must be knowing about this reinforcement learning. What basically is reinforcement learning? You know, this is actually concerned with how these agents take actions in order to maximize the cumulative reward. Okay, now one reward is for an agent, another reward is cumulative reward. Cumulative reward means last time जो मुझे reward मिला था उस उससे कितना ज्यादा reward मिला, ठीक है. So it will be like last time if I get 100, this time I got 50, so I am getting 150, but last time this another agent got 100 as the reward, this time getting 100, so the reward, cumulative reward of that particular agent, the second agent, is 200 now. So competition comes into the picture. Okay, so cumulative reward is getting, so this is what the concept behind reinforcement learning, यही basic concept है. इसके बाद जो algorithms है and all, you can go and read about those algorithms and implement them, you know. Then collective intelligence algorithms. Now there are a lot of agents, they have different levels also. Now how the intelligence algorithms are applied so that collectively, so that the system is coming to an equilibrium point. This is what the concept behind collective intelligence algorithm. Okay, we want the system to converge to an equilibrium point, and what is that equilibrium? The system must be balanced. Okay, reaching agreements, very important, है ना. So this is also one learning mechanism. Then comes your options. In reaching agreements, we have different algorithms. One is the algorithm of auction, like winner determination, first prize, second prize kind of auctions, है ना. Auction protocol, कॉमन नॉलेज बेस्ड ऑप्शंस, ओपन क्राई. ओपन क्राई होता है ना, जैसे फिल्मों में दिखाते हैं कि मेरा $200, मेरा 2 लाख, मेरा 4 लाख, उसको बोलते हैं ओपन क्राई बेस्ड ऑप्शंस. ओके, सील्ड बिड, जो टेंडर्स निकलते हैं ना सील्ड बिड गवर्नमेंट के, वो मोस्टली दोज आर नोन एज सील्ड बिड ऑप्शंस. ओके, एंड व्हाट इज मैकेनिज्म? वन शॉट में आपको वो ऑप्शन चाहिए, या आपको असेंडिंग, may be possible that a lot of times the either the work is getting increased or the amount of is getting increased with work, something like that. Okay, so that comes under option. Then negotiation based learning. Okay, I have already discussed negotiation. What is that negotiation? And then argumentation. This is also very important, you know, argumentation. So argumentations में बहुत सारी चीजें आती है, जैसे कि आर्ग्यूमेंटेशन में क्या आता है कि मशीन, आप जो है let us suppose persuasion. Agar there is a conflict of opinion, then how you are persuading? One agent is persuading others. Then, if conflict of interests is there, then negotiation comes as part of arguments. If there is a general inquiry, then inquiry kind of dialogue comes up. If there is a need of action, then deliberation kind of information is there. If let us suppose there is a spread of knowledge required by the agents, then information must be known, and that information spreading how it takes place. Okay, then so what I'm trying to do is कि see ऐसा नहीं होता है कि भाई आई एम गोइंग टू डेवलप लर्निंग एल्गोरिथम बेस्ड ऑन आर्गुमेंटेशन. अब आर्गुमेंटेशन में डायलॉग्स को कैसे लोगे, है ना? डायलॉग्स को कैसे लेने का मतलब क्या होता है? जैसे कि मैं आपको एक बहुत सिंपल सा सिनेरियो बता देता हूँ. इज देयर अ कॉन्फ्लिक्ट? दिस इज माय very basic question. Is there a conflict? If you say, sir, so my next question could be, is resolution the goal? By resolution of conflicting, agar conflict hua hai, so is resolution of that conflict is the goal? So your answer could be yes. So you can go ahead और persuasion करो, एक दूसरे के साथ बातें करो, you persuade, try to persuade. If resolution is not the goal, then there could be another scenario. Is settlement the goal? है ना? Resolution नहीं करना मतलब क्या करना है? Settlement करना है. तो जब सेटलमेंट की बात आ जाती है तो उसमें क्या आता है? नेगोशिएशन आता है. करेक्ट. सिमिलरली मैंने जो क्वेश्चन इनिशियली पूछा था, इज देयर अ कॉन्फ्लिक्ट, यू सेड यस. अगर आप कहते हो नो, तो माय नेक्स्ट क्वेश्चन कुड बी कि भाई इज देयर if there is no conflict, then is there a common problem to be solved? So if there is a common problem, तो क्या उसके उसमें कोई theoretical problem है, कोई practical problem है ना? अगर मतलब practical problem नहीं है तो क्या only information गेनिंग और इंफॉर्मेशन सीकिंग काइंड ऑफ प्रॉब्लम है? तो देखो इसमें क्या है ना कि आई गिव यू इन दिस पर्टिकुलर टॉक, आई ट्राई टू गिव यू those topics, those basic understandings from where if you start tomorrow, you will be actually seeking or you will be trying to search for the those topics. You can search for those topics and you can come up with you can think on your own and you can come up with the results, or you can come up with the solutions to a particular problem in multi-agent systems. Only advice that I can give you over here is that when you are trying to map any problem in real world on machines, first think how that problem will be solved by the human beings who are living in the society, because you are the programmers, correct? So first of all, before implementation, you must understand that the biasness associated any solution must be removed. Okay, जैसे कि मैंने आपको बताया था प्रॉब्लम ना कि दो भाई हैं, दोनों भाई को मार्केट भेजना है ना? तो पहले इनिशियली तो प्रॉब्लम हैड अ लॉट ऑफ means the solution had a lot of biasness. Then different problems, more problems came, and then more refined solutions will come. And what will happen? More refined solutions means वहां पे biasness कम होगी. जितना biasness कम होगा ना, your machines will become intelligent, but not at the cost of biasness. So वहां जो results produce करेगा ना machine, that will be the accurate and precise result. Okay. So with this, I am trying to rest my words. Okay, I am trying to stop over here. Thank you very much. I am open for queries.
So now we will be having a question and answer session. If anybody wants to ask any question, he or she can put that in the chat box or can unmute themselves for the same.
Oh, you are free to ask any question. Actually, I don't know. You don't know me. I'm a very calm and cool person. If you have any questions related to your...
Yes, I know this personally, that sir is very calm personality. Don't feel that sir will say that you don't know this thing. He is having that habit to explain each and everything with lot of patience. So you can ask, no problem at all.
Sir.
I'm listening.
There was some CLRI or something like that. Was it a research paper kind of thing from where you discussed this thing, or?
I wrote there. It is actually a proposal.
CLRI, right? You mentioned CLRI model.
Yes. Actually, it was a research done by two researchers. I gave the name over there, Vidal and Durfee. In 2003, this particular paper got published. So that was the model of as part of the general theory of learning agent, CLRI model, and it actually was published in 2003. You can search by the name Vidal and Durfee.
Can you spell what is it? Can you spell, sir?
Okay. I can show you in my slide also, I think.
Okay.
So
because sir, I tried, but I couldn't. You can
Vidal and Durfee. You can see over here.
Just a second.
Vidal and Durfee.
Vidal and Durfee. Yeah.
Yes,
Method to analyze. Just a second, sir.
So this was actually proposed by these two researchers, Vidal and Durfee. And it was actually a very good model, initial model of learning from where we can start implementation. That's why I tried to discuss this particular aspect. Okay, and then very complex theories also got developed because the problems that we are actually trying to address in real world scenarios, those problems are very complex in nature. Okay, especially if you see the IoT, take the concept of IoT. You know, when I'm saying agents, what are those agents? Those agents are actually the devices or the machines which are getting deployed and they are getting connected by IP addresses. And so what when we say some machines are there, they are connected by IP address, it is IoT. But the real problem comes when we address the issue of homogeneity versus heterogeneity among those devices. So as the heterogeneity increases, and heterogeneity could be at any level, like the size of devices, the size of size of devices, the communication characteristics of those devices, even the way the hardware is, means device characteristics are there. Okay, so there in the learning means certain level of assumption changes, and we have to come up with a common assumption wherein we can propose the solutions for learning in multi-agent systems. Okay. I hope I am clearing you down.
Okay, sir. Thank you, sir.
Anyone else?
Sir, I was having one. I have seen the Arduino. So is that a type of multi-agent system?
Oh no, see,
only the
Arduino is a microcontroller. Am I audible to you?
Yeah.
Okay, so Arduino is a microcontroller, correct?
Yes.
So you don't know. Okay, fine. I'm telling you. So you see, Arduino is a microcontroller. Raspberry Pi is a microprocessor. Okay. So what happens, like when we say Arduino is a microcontroller. You are trying to use it to control certain sensors or certain activities that you are developing, certain applications you are developing. Fine. So Arduino is a microcontroller. Now, when you are saying that it is an agent or not, you can make that particular Arduino an agent when you follow that structure where your perception is getting mapped to the certain actions. Okay, so always remember. Okay, so there is a difference. Sometimes people say that Arduino is an IoT device. No, Arduino is not an IoT device. But to make an IoT device, you have three important considerations. One is it should be an object besides computer. A computer may also be considered as an IoT device. So an object, you take an object besides a computer, okay, and you add computational intelligence to it, and then you add a network to it, IP address based. When it comes, when these considerations come, then it becomes an IoT device. Now, whether it is an IoT device, sensor device, or some other device, it is an agent or not, it depends on whether it is following the same structure that I taught you, that is a function that maps from perception to agent. Actions. I'm sorry. Okay.
Okay, fine, sir.
Thank you.
So there are not any more questions. I see.
Okay, thank you.
So last but not the least, I would like to thank. Yeah, last but not the least, I would like to thank our special guest, Dr. Saurabh Kumar, who, despite of his busy schedule, has found time to grace the session with his valuable knowledge. And I also express my heartfelt thanks to Mrs. Sonal Patil, ma'am, for taking one more such initiative, resulting in the organization of this session. I thank all the distinguished invitees present here who accepted our invitation and attended the session with utmost patience and attention. I hope all the students would have enjoyed the session and learned something new which can upgrade their knowledge. Again, I request all the participants to stay connected with us through the WhatsApp groups for the further sessions, and do attend the quiz which will be shared with you at the end of the day. Do fill the feedback form which is shared in the chat box also.